So the outline for today, I'll be covering the mission planning overview. Sean will go over rules of thumb and challenging environments. And Andy will talk about tools and resources. Then we'll give you links to different breakout groups, and you can visit 4 different flight planning sessions. We choose that you just usually stick with one. So that's Pix4D Capture, Drone Deploy, DJI Pilot, and Emotion. We won't be talking about Precision Flight app today, and we'll spend about 20 minutes in each of these breakout groups until about 2:50 p.m. We also recommend you checking out the related sessions from today and tomorrow that you can see on the right-hand side of the screen to get a little bit more information about mission planning. And you can find more information about these sessions in the DroneCamp online program. All right, so let's talk about mission planning. What is mission planning? Well, I'm glad you asked. Let's walk through some of the lingo. A mission is a drone flight or series of flights, and the plan relates to all the things that we have to do to prepare for this. So this could range from checking the weather, gathering equipment, charging batteries, and checking airspace regulations to getting out into the field and flying, capturing the imagery, and thinking about how we're going to process it. So mission planning is the general term for what we do to prepare for our flights. Flight planning is thinking specifically about the path that our drone is going to take in the air, as shown in the image on the right. So that's the drone in the air looking down. Considerations like how high the drone will fly, the pattern it will fly in, and where it will take off and land are part of this flight plan. We can create a flight plan with apps like the ones you'll hear about in our breakout groups later today. Flight management software is about the different apps that enable your drone to fly. So this could be with a flight plan or just by flying manually. And there are tons of these apps, and some are specific to your drone. So for example, DJI has several apps that they make for their specific drones. When flying, this is usually the first app you're going to connect to your drone, and then you can often switch over to a flight planning app and then fly that path that you saved previously. A ground control station app is basically an app that allows you to create a flight plan and monitor flights by communicating with your drone using wireless telemetry. You can often see video streams, camera shots, altitude, speed, and different parameters, and it connects to various satellites for more accurate GPS positioning. Autonomous flight means that you're using a flight plan to fly your drone. It's kind of on autopilot, so you're not steering the drone as it flies. So why mission planning? That's a great question. Why wouldn't we just want to go out into our field site with our drone and fly when our heart desires? So a couple of reasons. Number one, if you plan out your missions, you're going to get better data. For example, you can figure out the best times and days to fly based on the sun's position in the sky or the weather forecast, and you can create a flight plan to get a 3D image if you want to, and so on. So the more you're able to prepare in advance, the better the quality of data you're going to be able to feed into your photogrammetry software. Another reason for mission planning is replicate missions. So say you're interested in analyzing the phenology of a specific plant throughout the seasons or years. You'll want to set up a nice flight plan and fly this exact location every year or season to see the change in this plant. And planning for this type of mission will enable you to do that, so that you have a nice time series and it makes change detection a lot easier for your target species. Number 3 for mission planning, it's automated. So with a lot of these apps, you can just click fly and the drone will take off, fly the plan that you programmed, and land all on its own. You can just kick back and relax, and of course intervene if the drone tries to fly away or run into a tree. Also, automated flight plans help reduce error, and that'll get you much better data. And this will often tell you if you're in a safe fly zone, so away from airports or restricted locations, which can be really helpful. But we would recommend you checking these air restrictions in advance as well. And number 4, it's just really fun. There are tons of different apps to choose from. Some that can help you get 360 panoramic shots, some that can help you build 3D models. They're really fun to explore, so I hope that you join some of our breakout sessions later today. So now we'll talk about some of the inputs into a mission plan. Things to consider when planning out a mission include first thinking about your project goals. So what sort of data you want to collect, when you should collect it, and how much you should collect. So kind of the study area size. Also the spatial resolution or ground sampling distance you need to detect the features within your study area, and what drone and sensor will get you these data. Also, if you need spectral calibration, like for multi-spectral or thermal imaging, you'll have to plan that out in advance. So a lot of this is a balancing act. You need to juggle your goals and aspirations, like the drone and the sensor that you want to fly, with a lot of constraints, like airspace regulations, site access, where you can launch and land your drone. Time plays into it, money, batteries, and if you can charge your drone in the field, weather. You don't really want to fly in the rain unless you have a waterproof drone. Sun and shadows or reflection from the sun if you're flying over water, that's a big consideration. And how you're going to process your drone data. So really important to think about these constraints before you get out into the field. And what do flight planning apps have in common? They use photogrammetry. If you're unfamiliar with this term, you'll hear it a lot throughout DroneCamp, and this is kind of our first introduction, but it's essentially how we get reliable information about physical objects in our environment using photos of the same location, but from a variety of perspectives, as you can see here on the slide. Photogrammetry includes how we collect aerial imagery. In this case, you can see the airplane taking multiple photos of the same location from different viewpoints, how we process the data, so you can orthorectify this image to create accurate locations within our map, and the products that we can create from this process, like orthomosaics and digital elevation models, which we'll talk about in a minute. Flight planning apps incorporate photogrammetry by figuring out things like how much overlap is needed in each image, or the angle of your camera to create products like a digital surface model. There are a lot of different really cool flight plan types. I recommend trying them out. Here are some examples from Pix 4D Capture app. So the grid pattern that you see on the left crisscrosses your study area and can be fairly quick depending on the height and the size of your study area. And this is for 2D maps. If you want a more detailed 3D map, you can use the double grid that you see in the middle. At the same altitude, the double grid will take longer and use up a little bit more battery than the 2D, but it'll provide a lot more information. The polygon flight plan allows you to have more control over the shape of the flight plan, so you can just drag those edges around to more perfectly fit your study area. And this is for 2D maps as well. This circular pattern that you see here will help create a 3D model of an object within your study area. So think a 3D model of a tree or a statue. Free flight allows you to use the controller and control sticks to maneuver in manual mode, and multi-battery allows you to land your drone mid-flight in one location, load a new battery, and resume flight in the same location. So again, many different flight plans to choose from, lots of good options. They just depend on what kind of data you want to collect. So for the photogrammetry outputs, these are the types of products that you can create using these apps and using the principles of photogrammetry. So you can create things like an orthomosaic, which is basically all of your photos stitched together and ortho-rectified, so it has accurate positioning within your image. Vegetation indices to look at vegetation health. A point cloud for 3D analysis and volumetric measurements. A digital surface model to understand the height of objects within your study area. And a textured mesh to visualize objects in your study area in 3D. And all of this is done using the principles of photogrammetry. Okay, great. Now we'll kick it over to Sean, and he can talk about rules of thumb and challenging environments.
Great, thanks, Chippie. If you wouldn't mind flipping slides for me, that would be fantastic. Okay, so rules of thumb for challenging environments. Can everyone hear me good? This looks like, all right, good. Yes. So the first thing I want to think about is visibility. And this really comes into play when you're talking about flying in forested areas. It makes it very challenging to be able to see your drone at a distance, of course. And as Brandon was was talking about earlier, it's important that you can not only see your drone in the sky more, but also to see its orientation and the direction it's flying in case you have to return back to your home point manually. And that gets just exponentially harder when you have trees surrounding you. There's some strategies that you can use to get around that. For example, we've used what we've done with our EB in high relief terrain is launch it from a given site, let it circle above us. This is in a rural area, by the way, circle above us, and then drive up to a good vantage point, then watch it fly, let it return to its location while we can still see it the whole time, then let it come down for the landing. So there's a variety of strategies you can use to get around the visibility limitations. For large areas, it's a good idea to plan your missions so the mission comes back to yourself. And what I mean by that is if you want your starting point to be as far away as possible and the ending point to be as close as possible. Because at any point in the mission where something can go wrong, you want to return home as quickly as possible. And examples that pop to mind are which we've seen is when you have a battery malfunction and all of a sudden you see your battery power on your application ticking down really fast. You don't have much time to get it back home or before it falls right out of the sky. And so if it's closer, then that's good. Another factor is if there's wind. If it's far away, it might take a lot more battery to return to you than you would expect. And many people, including myself, have been surprised with how much that wind can make a difference. When it comes to large areas also, you want to think about planning your flights so they're consecutive flights. So where one ends, the next one begins, and you want to do that as quickly as possible. That way you can stitch all your imagery in one process and you don't have seam lines that can create problems with your mapping and your analysis later on. Challenging terrain. This is the bane of a lot of drone operators. You want to launch from the highest altitude possible. And I'm sure I'll repeat this throughout this section, but I've seen excellent drone pilots, some of the best I've ever known. And they've crashed their drones into the tops of hills or trees because they misjudge the direction and the altitude of the trees or the hills adjacent to them. So launching from the highest altitude possible will help alleviate a lot of that. Challenging conditions. Mission focus is sometimes not to be taken lightly. You'll get out in the field, you really want to get the job done, and this will lead to risky behavior sometimes, pushing the batteries to the limit, trying to fly in too high of a wind, putting too much weight on your drone for the altitude. There's a lot of these things will come to haunt you, and it'll ruin your day or your pocketbook when your drone goes down in I would say a ball of flames, but yeah, you get the point. The flying over challenging surfaces it can be a problem, and one that comes to mind is grassy areas when it's very windy. I've flown in windy areas before where the whipping of the grass makes the photogrammetric processing almost impossible. There's no tie points to be able to connect to. One strategy for that is to fly higher. If you're flying at a higher elevation, a piece of grass that's waving back and forth will still remain inside of the pixel at least a little bit longer, and you might have more contrast area based upon shade and other things that might allow your photogrammetric processing to occur. Next slide. Overlap. Overlap it's variable. And what I mean by that is it really is dependent upon the type of terrain that you want to collect data over. Conventionally, from the past, using old stereoscopic air photos, the rule of thumb was to have 60% side lap and ballpark of 75 forward and back lap. And if you see the diagram to the right, this is what it's indicating. Each photo in a line, in this case, something looking like a lawnmower pattern, each one of these photos has a certain amount of overlap with the next one. And when you get to the photogrammetry section, this will make a little bit more sense. But the key thing is that you need to have a number of look points on the ground to create a really good three-dimensional stitch between the images into one single ortho mosaic. And if you don't have enough overlap, it just won't work out for you. This is especially true, next slide, in agriculture or dense vegetation or tree cover, where you really need to bump it up to a minimum of 85 on the forward lap and 80 on the side lap. When I fly in something like a coniferous forest, like a pine stand, I'll bump these up to 90%. Another thing to consider too is when we're setting up your mission planning software and you're running more than one camera on your drone at a time, the field of view of each of the cameras might be different. So when you're flying with, say, an X3 on a Matrice 100 at 90% overlap, the actual overlap of the red edge that's also on the drone might be around 78%, if I remember right. You can look this up and do the calculations yourself on Excel, but it's a consideration you need to take, because often you do want to collect data with more than one camera simultaneously. Avoid windy conditions. I can't stress this too much. Windy conditions can take a drone out of the sky, particularly on an autonomous mission where they take the turns, and if they get caught by a gust just the wrong moment, it can take them down. Another thing that this is just aside from the mission planning, if you're in the field and you see your drone turning at different angles that don't look right, the flight controller might be a little bit confused, because wind will interfere sometimes with the stability of the drone and its orientation. The aim for a 5 to 10 centimeter pixel GC ground sample distance, GSD. That's essentially the average pixel resolution on the ground. This is a good rule of thumb. To get in the 5 to 10 centimeters is roughly 2 to 4 inches. Less than that, you'll end up having more data than you usually need, and you can't discern what is what, like if you're looking at little teeny leaves or something like that, if the resolution is too great anyways. Next slide. All right, so there's always trade-offs with drone operations. One of them is altitude. The higher you fly, the larger the footprint that you can cover. The lower you fly, the finer the resolution. I kind of alluded or said before, lower is not necessarily better. You'll sometimes get much higher fidelity, better, cleaner, higher contrast imagery or outputs if you fly at a higher altitude. You also can cover a lot more area when you're at a higher altitude. If you fly near solar noon, this is preferable. And this is all times of the year. As the sun goes down in the horizon, especially in the twilight hours, shadow angles change really fast, and you won't have the necessary reflectance from the surface of the leaves to really conduct great analysis in some cases. The digital surface modeling is hampered by that. So if your goal is to create a good digital surface model or digital terrain model, which we'll touch on those terms later in the DroneCamp, if you're looking at your elevational modeling, the shadows aren't as important, but for spectral differences, yes, flying at solar noon is good. The thing there is that we're assuming that it's a cloud-free day. If you have just solid overcast cover, that will eliminate a lot of the necessity to fly that close to the solar noon. Usually it's a good idea to make your footprint of your flight around 10% larger than the footprint of the area that you're interested in. The areas beyond the edge of, say, this flight plan they're compromised both spectrally and spatially by panoramic distortion. Because of the imagery, when it stitches together, and I mentioned before, you need several different look angles to really truly get a good color match, as well as a good excuse me, I got pop-ups on my screen. Hopefully you're not all seeing that. If you won't have you just won't get good representations of the surface that way. Again, both spatially and spectrally. Fly parallel to the wind to reduce canter. This is most important with a fixed wing drone. The fixed wing, if you're flying with a crosswind, you'll end up having the drone flying with a canter, so you're taking images at an oblique angle, and when you take the next turn will also have a oblique angle. This isn't ideal for good mapping. I'm gonna skip, I'm sorry, I gotta skip the bottom one because I don't have, I have a pop-up in front of me. There we go. Oh, fly parallel to the sun too. So in line with the sun angle, if possible, that's a good idea. There's something called bidirectional reflections distribution function, which is a complex way of saying that the sun reflects forward, bounces off of things more in one direction, and then you get more shade on the other sides of objects. And the combination of that from looking at the same object from different angles will create a different spectral characteristic. And so the color balancing processing in the drone will alleviate a lot of that, but that is the most extreme along the horizontal landscape angles of the image. And by flying directionally with the sun, the lesser overlap on the forward and back lap will not accentuate that issue as much. Next slide. Yeah, again, flying with, I already spoke about flying with the wind with a fixed wing is a good idea. It is really important though to be conservative with your battery life. If anything's going to go wrong, it always seems like it's at the very end of your mission, and you don't want to get down to 10-15% because you got to consider that as almost zero. If you get below that level, and on some platforms, they'll automatically land on their own. And that's a safety function because you just don't want them to suddenly stop in midair. And I already talked about finishing your missions close to where you started, but also flying back with the wind direction is important. Next slide. If you, and I'm going to, some of these are a little bit redundant, but launch high from a higher position is a good idea. You also have better GPS reception from the higher location as well. I've had this, especially with the 3D robotics solos where they have bad antennas. Taking off and landing from inside of canopies is really hard where there's just not enough GPS reception. A flat area is great. Level is even better. Fly away from obstacles. You got to avoid obstacles all around you, and situational awareness will save you a lot of issues in the long run. Try to plan your mission so your sun is at your back, if at all possible. The last thing you want to do is be staring into the sun for your whole mission. There's also strategies you can use with using a hat to be able to shade your eyes at just the right angles, and then having your approach stop before it gets to you so you're not looking straight up at the sun when it comes down. Where you mentioned the downwind idea, having it fly back with the wind. Minimizing the time between flights is important, and using a landing pad is really a good idea too. Maybe not once you can get away with it, but if you do it over and over and over again, you'll get a ton of dust inside of your instruments, and that can cause malfunctions. Next slide. Look up before you land. This is a real picture from one of our research and extension centers down in Southern California in the Imperial Valley. I mentioned before that even the best drone pilots, they make human errors, and including running into things like power lines, running into trees that are on slopes. There's but yeah, you have to look again. Situational awareness is going to help you a lot in this case. No matter how well planned your mission is, when you get to the field, you got to reevaluate what you're going to do, because or at least reassess to make sure that what you plan to do, it will actually work. And that comes to things like that are not necessarily the drone focus, but rather where you're going to be flying from. There's some projects within the UC system where you might be near car traffic. And so you don't want to be walking around looking at your drone while a car might come by and run you over. Crop dusters. I've had crop dusters buzz me before while I'm flying, and you have to look out for that too. You sometimes can't even see where they're coming from until they're right on you. Be wary of animals and insects. This seems like a little thing, but it'll get you. If you have like crazy dogs around you, I've had them go after the drones like it's a pinata in the air, and you know that's a worry. Also insects. Just the other day, when I was flying to collect some data for this drone camp, I set up the landing pad on top of an anthill unknowingly, and next thing I knew, I was covered with ants. So just little things. I mentioned don't launch and land in the sun. Know which way is north. It might be a good idea to have a compass out, but get your orientation down before you launch. We've seen, our team has seen an excellent pilot get turned around and fly their drone exactly the wrong direction into the side of a slope once. And then one other thing, high power lines can affect the signal to your controller connection to your drone. And so if you're flying on the other side of power lines, just take that into consideration. Next slide. Okay, something that's important is plan your battery swaps judiciously. Sometimes you might be able to fly further, but it's better to have your mission in prematurely so it's right over the top of you so you can get down, get a new battery into your drone, and then get it back in the air more quickly, and then your stitching will end up turning out without any light differences so much. And that, again, I mentioned plan your mission so one begins where the other ends. Something that's important, consider plan on having a number of GCPs out, particularly in areas like grassy environments where there aren't a lot of good high contrast points for key points to lock the images together. Another example I can think of is when I've flown in rice fields, GCPs were essential for being able to really correct the spatial calibration of the imagery. Processing the data collectively or separately. There's different ideas on this. I personally suggest processing your data collectively, and what I mean by that is if you have one mission next to another mission sometimes that can overtax your computer when it exceeds the level of RAM and the CPUs that you have to put into the project. But as large of an area as possible at once tends to be better, because then you don't have strange seams between them when you try to combine the imagery at a later time. And again, back to the mission focus. Don't be afraid to abort or resume. Next slide. So here's an example of a repeated flight. This is great, where you see there's an extra bit of overlap where they first where one ends and one begins. This is a good amount of overlap. There's a bunch of overlap in the coinciding area. This last one is not a significant enough overlap, so this might not work out so well. Next slide. Few flat areas are okay. So look out for all these things. Flat areas are better. Road access is a good idea. I mean, when you hike out with your equipment that you don't have some resources available to you, there's a lot of obstacles and steeper terrain and away from the roads, and then strong winds around mountains. I've seen this before where it's nice and calm at ground level and you launch and there's a winds like 30 miles per hour higher above the top of the mountain, and this can take your drone right out of the sky. And this is especially significant in mountainous large areas. Next slide. Selecting a safe altitude. Again, don't overestimate your ability, and it's supposed to be able to control the drone as well as to react when something goes wrong, and something will go wrong eventually. And so the using topo maps is a good idea. Do test flights first. If you're a GIS person, you might want to do a view shed to see what might be visible from any given point in your area. And if your drone has obstacle avoidance, use it. Next slide. Okay, so hilly terrain. Next slide. So pros, safe, larger flight areas, software can handle resampling. If you launch and you fly over an area and you have, if you launch from the highest point and there's an extra level of drop off below, this is a little bit of a gray area in the FAA rules that you have to stay within 400 feet of ground level, especially if you fly over over a valley, like a sharp valley. So it's better to fly from the altitude of the tops of the hills or the tops of the trees. Cons, hilly areas require high launch points, so that's what I was getting at. Flight areas may be farther away and larger variables of ground sample distance. Sometimes you need to break these flights up and then repeat flights over the highest areas if you're flying from a little bit lower, because there'll be less overlap in your flight area uphill from you than there will be for the areas downhill. Next slide. So multiple flights, this is what I was getting at. You get a smaller ground sample distance or spatial resolution and a more consistent ground sample distance. The problem is you need to fly a lot more times, and it's harder to maintain a line of sight in some cases. And there's also a higher collision risk. You have to plan this out pretty well. Next. And then there's some applications like the eMotion app for the EB that will do terrain following as part of the functionality. This is fantastic. I'm really looking forward to this becoming more common with the quadcopters in the future. Cons, it requires a very good app and an accurate elevation model. If the elevation model is bad, that could be a problem. Next. Challenging ground cover. Turning to this, there's lower texture in some areas like sand and snow and water. I was getting at that, like rice fields. There's not enough contrast without texture. Tall grass is small and similar in detail, and so especially if it's waving around, it won't look like to the software. You won't be able to recognize key points as well. Moving objects are a problem, and glint. Collecting imagery over water used to be all but impossible with photogrammetric software, but now that's improving a lot. Next. So if you have low texture, you need to increase your overlap, and smaller detail, you increase your overlap. For moving objects, higher altitudes are good, and glint, flying from higher is also good. It reduces the glint effect. The fly lower for low texture. You might want to do double grid, and that means instead of flying a lawnmower pattern forward and back, you would double that up. So you would go, say, north and south on one set of flight lines, and then east and west on the next set of flight lines over the same footprint. Enlarge the area of interest if you have low texture, so you get more contrast points with a larger footprint. And then with same thing with smaller detail and the in-glint areas. Put GCPs out. One of the main things for GCPs is to replicate your results or to be able to fuse your data with other cameras' data and over time. If you don't need to do that, you might not need GCPs, but it does help in your stitching process if something doesn't work out. You can use those to recalibrate and rematch your images to get them to lock together more consistently. And then increase your camera contrast if you need to. Usually your automatic settings are preferable, but sometimes you can use manual settings and that'll improve it as well. Next. Ground control points. Have them well distributed around your area. Plan this ahead of time is a good idea. There's so when there's low visibility of contrast, these need to be out in the field. To get a precise geolocation for each of them, you'll need a high level GPS unit. Something like a Garmin's not going to do the trick. You need something that's going to be a finer resolution, much finer resolution than the GPS that's on the drone itself. Let's see. You might need this also for mosaicing multiple flights. So if you have multiple flights in a and then you're combining them together, and they have overlapping GCPs. That'll help you match your imagery much, much better. And then tomorrow we'll have our high precision mapping section that you might be interested in that will probably explain most of this stuff in much more detail. Next slide. Thermal data. Oh boy, this really is troublesome for a lot of folks. I mentioned it earlier, and we were talking about the instruments. Thermal data is challenging because thermal values change really quick. The wind changes, you might have a different thermal value, and then you won't have the same kind of contrast point for stitching your imagery together. To help improve or to deal with this problem, having higher overlap is a good thing. The problem is with higher overlap, you can cover less area with the same battery power. And the problem with a drone flight is that, and Becca mentioned this earlier, is over the course of your flight, thermal values will change. So you'll have a sloped or a ramped up effect if it's getting hotter, or a ramped down effect if it's getting cooler. And that's a problem too, because this isn't, when the drone flies, it's not an instantaneous capture. So, but the higher overlap, conversely, will help you get a better color balancing and stitching results. Flying slowly is important also, because the thermal cameras tend to have very, well, especially the ones that go on drones now, have very, very small sensors. And so you need to, there's just not enough photons reaching that sensor at a high speed to keep good fidelity. So slower is better generally. 4 meters per second for a high altitude flight. If you get down to, like, say 100 meters, you got to drop that below 3 meters per second. Take RGB images as well, and then make your missions small. If you try to cover too big of an area, nothing's going to work out. It's better to have something good that's small than something big that doesn't work at all. So consider that. And then flying in low humidity. High humidity is going to cause all kinds of problems with the thermal effects, because it removes contrast from the scene in general. Next slide. Part 3, I'm going to turn this over to Andy.
All right, thank you, Sean. Can everybody hear me okay? All right, so I'm going to go quickly through some of the tools and resources. So as you saw from Chippie and Sean, there's a lot to think about when you're planning missions. Go ahead, next, please. So fortunately, there's a lot of tools that are making this a lot easier. So there's these are some of the. Is that me echoing, or so? Could somebody check the participants window and mute whoever's echoing? So there are a number of apps that run on mobile devices that you can use to plan your flight, to actually run the flight. So the app actually flies the drone for you. That's not technically correct. It uploads the waypoint and then the drone flies itself. But they do all of the hard work for you, and you just have to know the principles of drone mapping missions, and it'll do the hard part for you. There's many apps that do this. These are some of the ones. We're going to demo some of these this session, except for Precision Flight. We had to cancel that one at the last minute. Next, please. There are other ones as well. And these are some of the other ones that you can use. If anyone has experience with these, I would invite you to chime in and put in your chat window if you like or dislike these ones. All right. Is anybody else hearing the echo?
I'm not, Andy. You sound great.
Okay. Next. I'll talk a little bit about the tablets. So you can certainly run these apps on phones. Most people who are doing this for work purposes prefer tablets, mostly because the screen is larger. Sorry, I'm going to have to switch audio. Give me 1 second here. I'll switch to computer audio. All right. Okay, I'll keep going. If you do use a tablet, get one which is not your low-end model. Get something that has a decent processor, is solid, A good bright screen is a useful feature. Probably want at least 8 or 16 megabytes of RAM. And then we like the ones that are maybe in the, the 9 to 10 inch form factor. Next. Some features that that are less important will be your, expandable storage. There's lots of bells and whistles for special features that high-end tablets come with. Those may not be that important or helpful for drone mapping. And here's some of the terms that you might search for. You find out on forums what other tablets people are using. Gaming tablets tend to work well, but avoid those, $24.99 tablets. You'll be disappointed and your tablet might freeze up, and that's a real annoyance. Next. Keep your tablet clean. This is a general recommendation. Don't put every app in the world on it. Keep your kids' apps off of it. And keep it in good shape for your drone mapping. Next. Practice with everything about drone mapping, whether it's software, flying, mission planning, do some practice. You do have to learn some things about running your tablet that you may not normally have to do, such as how to close the apps, how to manage your updates, and so on and so forth. Next. So these apps for planning your flights, they do all the hard work for you. And they're well developed, and they're mostly free. There's a couple where you have to pay something, but you can get very good featured flight management apps for free. Sometimes they're from a company like Pix4D or Drone Deploy, and they are making them available for free in the hopes that you'll use their cloud processing platform. But you can use them to fly the flight and then stitch the images using something else, like your own laptop. Next. Features to look for in the apps that you choose. Number one, does it support your hardware? If you're flying DJI hardware, there's a good chance that it will be supported. You want to make sure it supports your mobile device, whether that's Android or iOS. Another nice feature is the ability to change your flight plans easily in the field. To resume a mission that you may have to abort because it didn't quite finish, and then resume it on the next flight. To be able to save your missions and to export them. That's important, particularly if this is part of a project where you have to refly flights more than once. Some flights and some platforms allow you to plan missions online through a web interface. Some of the bigger organizational platforms have that ability, so one person can plan it for multiple pilots. It's nice to have platforms, or we like to have platforms that aren't tied to specific hardware, but there are those that are. And another nice feature of some apps is it gives you a kind of a quick stitch in the field to see if the data that you just collected is going to stitch nicely. If not, because it was blurry or the lines were too far apart, you'll know that before you have to go back out to the field. Next. In addition to those apps which fly the drone for you, you will probably need to use one or more other apps to configure your hardware, specifically the drone and maybe the camera. These are other apps, they're published by the manufacturers. DJI Go is a common one. Some sensors, particularly the higher end multi-spectral sensors, will have a different procedure to set the camera settings using a browser. So basically the camera puts out a Wi-Fi, you connect to the Wi-Fi with your tablet or another phone, go to a certain page and then configure the settings. Next. A good one that I always check is white balance. Sometimes you can change or set the white balance in the mission planning app. Other times you cannot, and you have to change it in the manufacturer's app. But auto white balance can get you because it tries to guess the color temperature based on what's under the camera at the time. If you just set it manually, you'll get a better color tone and have nicer looking data. Next. These are some other apps. I won't pause here, but there are a variety of other utility apps that drone pilots use all the time. Some of them help you check your airspace. Some of them help you plan your site, and so on and so forth. There's also various apps for recording your flights, and some of those are integrated with the aircraft platform and/or online platforms, but that's another good one because you do want to keep track of the wear and tear on your equipment. Next. We have some resources on our website. One which is just from last week. We have kind of a review of some various websites which are good for mission planning. You can see the different categories there. And then we have another one which is some of the lessons we've learned from mission planning to get good orthomosaic. Next. Okay, next. So at this point, we're going to put in the chat window links to some breakout rooms where you can talk to somebody who will talk through some of these apps. We don't have time, but let's take 5 minutes and give people a chance to see what these apps look like. There are also some slide decks on the different platforms that we're going to show that you might be interested in.